The story of a ballistic missile launch is an unfolding journey through engineering marvels, split-second timing, and the delicate balance of power. In this video, viewers experience each phase of a missile's ascent and descent, uncovering the purpose behind every controlled movement, every explosive separation, and every moment of intense calculation. Let's dive into this meticulous, highly choreographed process. The scene opens on a fortified missile silo buried deep underground. In the control room, military personnel conduct final checks on a missile equipped with cutting-edge technology. High-resolution monitors display vital information, fuel levels, weather conditions, and trajectory calculations. The air is thick with tension. Every eye is fixed on the data, each piece critical to ensuring the missile's success. Engineers and technicians confirm readiness, and with a final nod, the countdown begins. With a roar, the booster stage ignites, propelling the missile upward. The initial thrust is immense, powerful enough to overcome gravity's grip. Flames and smoke fill the silo as the missile bursts out, breaking free from its underground chamber and surging into the sky. This stage is all about raw power. It's designed to lift the missile beyond the dense lower atmosphere. As it ascends, the missile's body shudders under the strain, but this stage has only one job: to push the missile to a height where precision becomes possible. After the intense push from the booster, stage separation begins. The spent booster detaches, tumbling back to Earth, allowing the missile to continue without the dead weight. This separation must happen precisely on time. Even a second off could destabilize the flight. With this discarded first stage, the missile shifts into a more refined path. The second stage engines ignite, smaller and more efficient, perfectly calibrated to take the missile to the next level. Now operating with precision, the missile enters the mid-course phase. At this point, it's leaving the atmosphere and entering near space, where atmospheric resistance is minimal. The onboard guidance system makes small adjustments, continuously communicating with ground control. In this zero-drag environment, the missile's trajectory becomes smoother, its path guided by a combination of gyroscopes and computer algorithms. It's a phase of quiet but crucial movement, as the missile glides across a vast distance with only the momentum and micro-adjustments guiding its way. In this upper atmosphere, it's clear just how complex the missile's path is. Even the smallest shift in altitude or angle can throw it off course. Ground control monitors its every move, calculating and recalculating to ensure it remains perfectly aligned with its target. Here, we see how staging controls not only the missile's trajectory but also its energy efficiency. The second stage engines continue to provide controlled thrust, each second drawing it closer to its destination. Now the missile reaches its peak altitude. From here, it begins a controlled descent, entering the terminal phase. The guidance system prepares for re-entry staging, the final phase that will send the warhead into its targeted descent. This re-entry vehicle detaches and begins its plunge back toward Earth, shielded against the intense heat of atmospheric re-entry by advanced heat-resistant materials. Sensors on the missile adjust its position, compensating for the drag created by re-entry. Every second is crucial as it accelerates, building momentum toward the target. In the final stage, the re-entry vehicle approaches at blistering speed, guided by onboard navigation to ensure it strikes with pinpoint accuracy.